So in this year's game, robots are tasked to pick up cones and cubes and then put them on little shelves. Pretty much the low, you can put cube or cone anywhere, and then in the medium and high, you kind of have designated sections for the cones and cubes. And the entire goal of the game is to stack these cones and cubes on the shelves and kind of make rows of threes, and these are called links, and they score you extra points. And at the end, there's a little beam where the robots can balance on, and if you dock and engage it, you get a bunch of extra points at the end.
Our main strategy is to be a quick, small, speedy robot that can perform as many cycles as possible to maximize our scoring. But we decided that it was a necessity for us to also be able to score high.
So for the drive base, currently our length has to be 30 inches to be able to fully constrain the arm within the frame perimeter in stow for the start of the match. And we're trying for a 23-inch wide drive base so we can fit on the charging station with two teammates that are both at max dimensions.
So basically, the whole problem with our pincher was that it wasn't able to grip the cones, but it was able to grip the cubes well enough. And another problem was we couldn't decide on how to actually bring the cones over to the poles itself so we can put the cones on. We've decided to add this rubber material which can grip the cones better. We've also added in a wrist so we can turn over the arm and place it over top the head of the robot itself.
The roller claw is more of like a C shape where it has a roller in the front and a roller in the back, like where the C meets the middle. And so those two back rollers help the cone nose come in, and it kind of just grabs it in and keeps hold of it no matter how much it gets shaked. And then the cube comes in between the two rollers and it kind of just sits between them. And it's all driven by belts mostly. So we have a shaft in the middle that spins the belt from the motor, which spins the outside wheel, which then spins everything together.
So in mechanical, we have some big news right now as we've just gotten our new drive base, and we're in the process of assembling it, and it's going pretty good.
So what is happening in programming right now is we're currently working on getting the robot to align to Apex with the Limelight. So pretty much the robot is updating the positions constantly while it's moving. So it's obviously trying to get to a different position over and over again. So it just keeps oscillating over and over again. So that's just becoming a problem, and we're just trying to fix that right now.
Well, we split into two groups, and we're basically building a belt-driven arm and a chain-driven arm. For the belt-driven arm, we found out that it does retract an intake and retract and go back in, which is a very good thing, and we're very happy with it. We are going to test with more weight and see how it goes.
So success with the chain are kind of few and far between right now as we don't have the proper materials, but we are going to be working on motorizing the chain-driven arm, and that's all going to go down on Friday and Saturday, and hopefully we'll have a working prototype by then.
In the end, it came down to us choosing the belt arm design over the chain arm design, and the primary reason for this was that the belt arm design was much easier to service than the chain arm, because with the chain arm we kept having to stick our hand in, and we couldn't do it quick enough to do it during a match.
Okay, so we did the design review to decide between the pinchy and the roller claw, and ultimately the team decided on the roller claw. So we felt that both prototypes were really good, but we were leaning more towards the roller claw because it fulfilled strategies, goals for the robot a little bit more, and because of its touch and own it philosophy. We're not fully leaving out any designs. We're still going to keep the pinchy in the back of our minds, but for our first competition at Hatboro, we've decided to go with the roller claw.
So for the final comp bot, we've been basically just attaching things to the arm and changing things and editing it just so that it works in in a game. So it's basically just been attaching the inner stage and the outer stages of the arm, the shoulder gearboxes, the belt drive gearbox. We have to get it done by the end of this weekend.
So for the final preparations of the robot, we are fixing the problem of the belt snapping. So we cut a slot through it and we're wrapping it around a tube so it doesn't snap right in the edge, so it doesn't snap in half when we're playing on the playing field.
So we've been working to remove the backlash from the gears so that the intake isn't flopping around a ton. And then the servo that we have for the locking mechanism is burning out over time. So we're looking into replacing it with a tiny piston so that hopefully we don't have that issue anymore.
Well, I really want to see the robot work. That's like the number one thing. We've had a lot of, I wouldn't say issues, but we spent a lot of time on the robot, or at least I have this season, trying to troubleshoot multiple things, and I really wanted to see it work.
For Happer or Horsham, I'm looking forward to be able to work with the team and experience an actual competition since this is my first competition.
I'm really optimistic for our performance at Happer.